now that you know the basics of Go in terms of getting it up and running, as well as where to find the playground, we're ready to really start programming. And so how I would suggest you do this is to kind of watch the video and do it as a code along. So I'm going to code in the browser, and I would suggest that you have the video open and then open a Go playground. Remember, it's play.golang.org. And at the end, when you're done, you can click share and it creates a URL for you. So that makes essentially your playground savable. So at the end, make sure to click that. And the good thing about the code-alongs is in this way, and having them on video, is that maybe some parts you can go faster for, some parts you need to slow down or pause the video. I tend to type somewhat quickly, so if you're a slower typer, that can be beneficial to kind of slow down, especially in spots. But this allows us to kind of all be on the same page. So what we're going to talk about today is variables. Variables in this context of programming are very much similar to how they have a context in mathematics. So you might think of a variable in mathematics as some object or container that can contain different values as you go. So A may have, a variable named A may have value 28, and then it changes to have variable 42. So in Go, if we're going to declare a variable, or introduce a variable, we need to do what's called declaring it. So the variable declaration notation in Go is to say, first off, type the keyword var, V-A-R. That says there's about to be a variable coming, okay? And if we want to name it A, and we want to say that it has value 28, Go also needs one other piece of information. So it says, I need to know what type A is, and in this context, we want A to be an integer. So we could say equals 28. So int is the keyword for integer. In other words, Go won't be able to read A is equal to 28. Okay? It needs var, saying a variable declaration is coming. A is the name of the variable. It has type integer, and it's going to be equal to 28. And if you want to change the value of A, we could say A is equal to A plus 14. All right, so we want to change it to 42. That could get weird. We can change it to 42 for now, and I'll show you. If we print A and print A again, then it prints the value stored in A. It doesn't change. It doesn't print the letter A. If we wanted to print the letter A, you could print it inside double quotes, like what we have for Hello Playground. But if you tell it to print A, it assumes you mean the value that's stored in A. Okay. You could also do A plus 14. All right, and I'll come back and say something about this probably in a bit. But it interprets this formula. We can already get weird here, where the variable A gets updated. So A is now equal to A, the value stored in A plus 14. Okay, so this is perfectly legal. You might expect that it wouldn't be. If you're a beginner programmer, that this would somehow cause trouble, that we have a variable and we set it equal to itself plus 14, but it's actually okay. For now, let me introduce the types. So the types, and by types I mean the commonly occurring types in Go. So these are the types of variables that we'll encounter. An int could be a positive and negative integer. Uint is going to be non-negative integers only. And in practice, you're going to use int more often than uint because ints can serve both purposes. You could have a float to 64. So it's a floating point decimal, so a decimal number. You could have a byte, and that represents a single symbol. You could have a string, and a string is a contiguous sequence of symbols, like hello world, which is in double quotation marks. That's read as a string. Okay, that's a string. And the final standard type that we have is called a bool. And a bool is a Boolean variable, and it can take two values, true and false. Seems relatively simple, but we'll see later how they wind up being really useful. Okay, so I said, here's, recall that this is the variable declaration format. Is var variable name, variable type equals value. Okay, so that's the standard variable declaration format. And you can declare different variables of different types in this way. So for example, you could say var x float 64 equals -2.6, or var symbol byte. So it's a byte type, meaning that it is a symbol. Symbol probably isn't the best name for the variable. And it's could equal, say, the letter C. So to indicate the letter C, a symbol, we use single quotes. So if it's a string called hello, then we use double quotes. Okay, and then finally, what about var statement bool equals false? Oh, it's a true. Okay, and then, so a quick learning point with Go is that all this code is fine, but if we actually try to run it, Go gives us a very common error, which is something we'll see frequently at first, probably, which is that if you introduce a variable, Go doesn't want you to have code that has anything extraneous in it. So if you were writing something, this is almost like a reminder to make sure that if you declared a variable that you actually did with it what you wanted to do with it. And if you don't do anything with a variable, if only all you do is declare it, then Go gives you a compiler error. So it says at lines 28, 29, 30, and 32, we have these variables that are declared and not used. And the easiest way to use a variable is just to print it. Now, you don't want to declare a variable that you don't use and then just print it for the sake of printing it, but this at least can get rid of the compiler error for now. And it'll print those values again. So we printed A up here, excuse me, A here of 28, -42, and then we printed the value of x, which is -2.6, the value of symbol, that's weird, 67. The value hello is the string hello, and the value of statement is true. So why do you think C didn't get printed as C? We'll come back to that. The next thing I would say would be, what happens if we omit? And from time to time, I'm just going to comment out things that we don't need. So I'll comment on all those lines. Sorry, one more we need. So if I instead omit the values of the variable declarations, so for example, if I did var x float 64, var sim byte, var hello string, var statement bool, okay, and I guess I need an int, don't I? Let's do var a int, okay? So everything else is ignored, right? Everything between these lines is being ignored because of the commenting. If I omit the values of the variables, then the question would be, what would happen if we print them? What is Go thinking of as each of these? So think about that for a second, and if I ever ask a question like that, feel free to kind of pause the video and think about it for a second. There's nothing, I would encourage that, but I'll go ahead and tell you that. Let's see what happens when we run it. So we get 0, 0, okay, that's so default of 0.0, default of 0, seems reasonable, 0 value, default of 0, that's weird. Okay, so we get another number. The string is what? Well, it's hard to tell. And then the default of a Boolean is false, as we can see was printed here. Okay, so let me move this down and print hello. So what do we see get printed? When we look at this line, we actually try to highlight it. We can highlight this line. We can see that there's no text there. It just printed a blank line. So the default is what's called an empty string. All right, so the 0 value for a string is double quotes with nothing inside of it. All right. That's it for omitting values of variables. It gets a little tedious to do all these variable declarations. So if we had multiple variable declarations, we could do something like var and then parentheses and then close the parentheses like that, tab. And you could say, let's see, I int equals -1, world string equals no. It's a strange name for a string named world. And say k float 64 equals 45.67. Okay, so it's going to be okay with this variable declaration because we're saying a bunch of variables. It's like saying a bunch of variables are coming. Okay, so I could print I world k, and you see why I do that, so that we don't get a compiler error and we see -1, no, 45.67 gets printed. Okay, so multiple variable declarations of the same type can be shorter. So if we wanted to say var and let's say m, n, and p, okay, and they're all ints, and I could give them 45, -23, and 109, okay? Then if I print m, n, and p, this is going to show us that what happens is m gets the value 45, n gets the value -23, and p gets the value 109. Okay, so it gives them the respective values, which is what you might expect. Next, let me comment all this, is that the variable declaration format of var name type equals value can get a little tedious. So we have shortcut declarations, and these are done with colon equals. Okay, so if you use, instead of equals, you use colon equals, you can get a shortcut declaration. So for example, I could say x colon equal -32, okay, and y colon equal 4, okay. Then this is the same as var y int equal 4, and that's the same as var x int equal -32. In both cases, it creates ints. So if you want a uint, you'd need something different. But in both of those cases, it gives us an integer. And this is the kind of thing where I want you to know both notations, and over time, as you start really programming, you're probably going to use this notation in practice a lot more because it's much quicker. Okay, I'll show that the values get set there. So symbol would be C, and print symbol, because that's going to be type byte. Okay, and 67. It's a bit odd. So we can do, again, I'll table that for now. We can do standard arithmetic on numeric types. So that means, for example, that if you want to say cat is equal to, and it doesn't have to be a single letter variable. It can be 2 plus 20. And if I print that, it should give us 22. And it's fine with that. So Go says there's a variable name on the left. Colon equals says we're declaring it for the first time. And then on the right, we take the expression 2 plus 20, which is 22, and assign it to cat. All right, what Go isn't going to like is redeclaring a variable that's already declared. So if we tried to do cat equals, say, cat, something like that, the string cat, and print cat, well, it's somewhat self-referential, but we actually get no new variables. So at line 78, no new variables on the left side, okay? Even if we tried to make it an int, it's still not going to like it. So Go is, again, really careful with you here to make sure that you don't declare a variable use it and then declare something else with the same name, because that could cause all kinds of confusion where you have two different values with the same name. You don't want to have that happen. So as a result, Go won't let you run this code. It stops you and gives you a compiler error, which is what you'd hope it would do. Other standard arithmetic would be, so if you had a colon equals 3.2 and b colon equals negative 2.6, something like that, we could set a equals to 2 times b plus 6 times a, all right? And so a gets reassigned 2 times the value in b plus 6 times the value that it did have in it. And then go ahead and print a, and if, I don't know what this is going to be out the top of my head, so cat was 22, and this value is negative 14.0004. So it's actually probably just, this is an interesting lesson, it's probably just negative 14, but there was a little bit of approximation error there. Okay, so it didn't give you an exact, it's probably just 14, but it didn't give you an exact number. So you can use, the right side of this is just a standard arithmetic expression. Next question would be, what about, and let me comment this out. So we've seen that if you said A is equal to hello and B is equal to world, and you did A comma B, and you printed A comma B, you're going to get a little bit of space here. But if you print instead A plus B is, so string concatenation with the plus sign. So it's the plus sign, it has two different meanings. It could be addition, and this is why types are important. If it sees two numbers, two integers for example, it adds them. If it sees two strings, it glues the strings together. So it needs to take different actions with the same symbol. And so this is why it needs to know what the type is so it can take those two different actions. If instead, and so I could do the same thing, let's say C colon equals A plus B. That's okay too, and I could instead print the variable C, and that's going to give me the same thing, which is hello world glued together. Next, I might say, what would happen if we did or let's say x colon equal to 3.1 and y colon equal to 2. And I just wanted to do something simple, like adding x and y. So you might stop and think, what's that going to be? Well, we would just immediately read that as 5.1, but the computer needs very precise instructions. And remember I said, it treats the plus sign as different in different contexts, and it's a very, very picky. So if we run it, what we actually see is invalid operation, x and y have mismatched types, float 64 and int. So it wants to see the same type on either side of this expression. So we have a plus sign. It wants to see the same type here as here. So the question is, what could we do then? And so if we want to make this, if we actually want to get 5.1, well, we could make that 2.0, but maybe we don't want y to have type float, because this would be type float 64. And this right now would be type int, okay? If we want to change it just for a second, so if we want to change just the value, we could convert the value stored in y, which is an int, to a decimal with float 64 of y, and now we're going to be okay. Okay, so y is still 2, right? But for now, at this part of the equation, it gets replaced with the float version of 2, and everything is okay. The next question I would ask would be, what if we do, say, ints? What if we say, and let me comment this out so we don't have too much clutter in the printing. What if we said q is equal to 3.1 and r is equal to negative 4.743, something like that. And we want to print, well, if we can do float 64 of a variable, why not say int of a variable? Let's do int of q and int of r. All right, and there's another point where we might stop and think, what's going to be printed? Okay, maybe there's a compiler error. Maybe it doesn't like converting 3.1 to an integer. And then what about r? Well, maybe it tries to convert it to -4, or it rounds it to the nearest one. And in practice, when we run this, we get 3 and -4. So even if we change that 3 to a 3.8, it's still going to give us a 3. Even if we change that -4.73 to a -4.04, it'll still give us -4. So we can see what's happening here is that it just chops off the decimal when you use int for a float 64. Okay, so it just takes everything off past the decimal. The next question I would ask would be, what about something like a is equal to 3, or I'd say 7, and b is equal to 3, and we want to do a over b. All right, so we can do addition, subtraction, multiplication. Let's do division and see what happens. So again, stop. What do you think might be? Well, what we would hope it would be 2 1/3, right? 2.333. Instead, what we see when we run it is 2. Okay, so what happened here is, well, we could do 8 over 3, and we get 2. We could do 9 over 3, and we get 3. So we're starting to see what's happening, and we could do -7 over 3, and then we get -2. So what we're seeing is that this gives us, so that would be -2 point something. So what we're seeing is that this gives us integer division, or chopping off the remainder. So it takes whatever the division is, and it just takes the integer component. It chops off the remainder. If you wanted instead to do 7 over 3 to be equal to 2.333333 repeating, then what we could do would be, well, you could declare a and b to have float type, so you could do that, or you could do var a float 64 equals 7, or 7.0. But instead, if you want it just locally, so if for the time being you want to just see the value 2.333, well, you could do float 64 of a over float 64 of b. And that should give us 2.33333, and so on. Okay, next question would be, what about if we do, okay, var g int equals the integer version of a decimal, 3.2. All right, so we've already seen that should just give us 3. But here's something I just wanted to point out. Go gets angry about this. So Go gets angry about, say, a type conversion of a constant. So 3.2 is a constant number. It's okay if 3.2 is in a variable. All right, this is a very minor thing that's probably rarely going to come up. But if instead you had x equal to 3.2, and then you do var g int is equal to int of x, then this should be okay. Let me just comment this out so we don't run into any trouble. Okay, so if instead I do that, g declared and not used, I should print it. So we should see 3. Okay, and we do there, 3. Let me comment this out. I want to do one more of these type conversions. Type conversions are relatively straightforward. And you can go back and forth uints to ints and so on. The one other one I wanted to show was that if you have, say, z is equal to 0, and then you wanted to do something like var OK boolean is equal to the Boolean version of z. You might expect that to be like false and like 1 to be true, but in fact, well, I've got to use FMT. In fact, what happens is that it cannot convert an int to type bool. So Go doesn't like this. Maybe in the future they'll change it, but for now you can't do something like this. Very minor issue, again, that probably won't come up often. But if you've programmed in other languages, you might try to do something like this because it might be okay in other languages, but in Go it's going to be a compiler error. Okay, so it can't convert an int to a bool. Okay, one more. is what happens if we do, say, a variable and it's an integer, let's call it u, integer, and it's negative 70, okay? And then we want to do var q, let's make it a uint, and let's make it the uint version of negative 70, okay? So again, I would say, what do you think might happen? Feel free to stop and think about it for a second. And let's do, if you're ready, I'm going to hit run. Well, I need to use print q. Constant negative 70 overflows unit. Okay, well, I gave it away a little bit. I meant to do u there. Okay, so we get this big number. We don't get, a lot of people think it might be either a compiler error or 70. Just take the absolute value of negative 70, but instead it gives us 429,496,7226. And then what about something like, well, let's say var I int equals, and I got to do a really specific value, 21474833647, and I want to print I plus 1, okay? Well, I could hope you would guess what that probably should be, right? And if we're doing just regular arithmetic, you just change the 7 to an 8. But when we run that, I get negative 21474833648. Okay, so both of these two kind of little issues have something in common, which are that variables have ranges. The variables themselves have to be stored somewhere on your computer. So there's a finite amount of memory that's being used for that. So that means that there's a range of values that a given variable can take. And on your computer, these numbers are probably a lot larger. So if you did this on your computer locally, you know, like running it through Go as opposed to the playground, you'd probably get for this first one 128446744073709551546. So a much bigger number, but it still causes something weird to happen. And so the reason is because of this ranging issue, I want you to see what happens here. So if I do 0 there, it's okay. As soon as I do negative 1, it goes to this number. Now take a look at that number and see what happens when I make that negative 2. So in other words, when this was negative 1, this is the maximum uint. It went from 0 to the very biggest possible value it can take. So when I go to negative 2, that's 1 less than negative 1. So it has that same number minus 1. So it's this minus 1. And if I change it to a negative 3, it goes down again. So it does 2. And if I change it to a negative 4 and run, it goes down 1 again. So if that negative 70, what it is the biggest possible uint minus 69. Okay? And so you can see here in the second case that this is the maximum int value. And if you do I plus 2, guess what's going to happen? That's the minimum uint value, so I plus 2 is going to be 1 more than it. Okay, so it's going to go up 1. So what's happening is you're getting a wraparound effect where when you go to the maximum uint or int value and go 1 more, in the int world it goes to a very big negative number, and in the uint world it would just go to 0 and keep going. And if you go past 0, you would go up to the maximum uint value, and so on. So this phenomenon is called integer overflow or overflow, because it's overflowing the space requirements that were set for that variable. And it's a good example of how, even though this is kind of the utter basics of variables, and it's largely a lesson on understanding and getting used to the syntax of variables, we start to see how we need to be careful, right? So if there's a moral, it's that even though this is simple arithmetic, we need to be careful when doing arithmetic of large numbers. Okay, so that might be the takeaway here at the end. where you might assume that doing arithmetic of large numbers would be easy, and if you did it on pencil and paper, you're going to get the answer there. But if you do it on a computer and you use big enough numbers, and again, these ranges are going to be much bigger on your computer probably, but if you use big enough numbers, then you're going to potentially run into an issue of overflow. This is something you need to be concerned with. For now, it won't be anything that we need to worry about, but it shows you a good example of how we still need to understand what's going on behind the scenes a bit when we're doing programming. Okay, next time we'll talk about functions and conditionals and see how they work in Go. See you then.